Okay, so welcome back. We're on about around page 300 talking about how prevalent the crew model is. Now, behind the scenes, believe it or not, how does memory get passed between the memory on the motherboard and the memory on the graphics card? Ooh, is that somehow shared? Yes, it is. They actually map a chunk of memory over here to another chunk of memory over there. So if I put something in, it can be zipped across the PCI bus rather quickly. There's a way that you can pull it directly from the CPU without having to go through memory first. So yes, there is an awful lot of memory sharing, but it's done at the hardware level, not at all at the software level. I mean, the crew model is doggone rare. Okay, so device drivers are kind of special cases because they can read and write two chunks of memory. But again, the device driver is not a user application. That's something written for the operating system, and clearly it's going to be running with administrator rights. And this whole concept of a memory map file, yeah, okay, that works, but it's just not very prevalent. Okay, so let's talk about some alternatives because the crew model is dang dangerous. So I want to write an application that is not that does not require administrator rights. So how do I pass data between two applications without having administrator rights? Well, there's an awful lot of choices. One of them is there's the whole concept of message passing. It could be used a thing called a named pipe. Don't worry about what that is. It's just saying there's a sort of like a network structure that you can create where you can push something in a pipe and it pops out the other end, right? Okay. There's one called a message queue where I can just say, put a message in a queue and it shows up at the other end. The other process can do it. There's a thing called a socket, which is a generalized kind of a network thing. And then there's one called remote procedure calls where I can pass things as parameters to other functions. Okay, so those are typically the techniques that you would use. So let me ask you, a typical Microsoft application like Microsoft Word or Microsoft Excel, which of these techniques does it use to pass data to another process? Well, none. Well, why would Microsoft Word or Microsoft Excel be passing data in anything? It doesn't use any of these techniques, right? It doesn't need to. So normal everyday applications don't do this. But there is a couple of examples that do. For example, if you have SQL Server installed on your machine, that is a service that runs as an administrator. Ooh, that's kind of important. And then there's a client piece which does not run as an administrator. Ooh, that's important. And when you want that client piece, like the SQL Server Management Studio, that's the client, to be able to talk to the SQL Server service, which is the service down here, well, then you get to pick. And so typically, when you configure SQL Server, you tell it, I want to use named pipes. I want to use, shared memory. I want to do. So the most prevalent way to connect is through the network, where it creates a network link between the two and passes it back and forth. So there are some applications. So any application you can think of where there's a client and server inside the same machine, okay, like SQL Server and SQL Server Management Studio, they're working inside the same machine. You get to choose. I mean, when you set it up, it comes up in choices. Say, hey, what are your communication choices? You say, well, I'll take that one, and that one. I usually select them all. Although security people tell you to kind of cut it down to all the ones you want. So yes, Microsoft SQL Server and the Microsoft SQL Server Administrator doodad, the Management Studio, use one of these techniques I just talked about. Okay. Now look, I'm going to skip the rest of this chapter because it's more philosophical. And if you were ever building a cluster from scratch, okay, and doing all this stuff, this would be really doggone cool. But how often are you going to be building a cluster and then writing code to run on a cluster? That's not very often. So I'm going to give you some honest-to-God, real-world things where parallel operations make sense and has nothing to do with clusters. So you can put the book down, and everything from this point on is stuff that's not in the book. All right, here goes. So let's talk about asynchronous programming. So asynchronous programming basically means that I want to start a task up and then go do something. Now, I like their analogy here. So let me just give you their analogy of what we're talking about. Okay. Asynchronous programming in this context means I can do more things rather than wait. All right, let me give you an example. All right, you're making breakfast. And so you could put the toast in the toaster and hit, pull the guy down and then just stand there in front of the toaster and wait. And do nothing, just wait. Waiting for the toast to finish, and then ding, the toast pops up. And then you go heat up the fry pan and crack an egg and scramble the eggs. Well, that doesn't make any sense, does it? Asynchronous programming would mean you start the toast and then you don't wait while it's toasting. You go get the fry pan and the egg and you start doing your thing. And then when you hear it go ding, then you take the toast out. So this is all about just killing dead time. Now, think about that. Did I add an extra cook in the kitchen? No. There's still only one cook in the kitchen, right? That means I am not using another task. I'm not using another thread. I'm not using another CPU. We're talking about one CPU and one process. Okay? Got it? Okay, one more time now. Not waiting for the toast. Still, that's just me in the kitchen. There's not two people in the kitchen. Okay? Okay? Good. Whew. Now, a real honest-to-God way of thinking about this is an example that I'm going to bring up here. So I'm going to bring up, okay, let me just finish. So is asynchronous programming, like we're talking about here, is that using multiple CPUs, multiple cooks in the kitchen? No. All I'm doing is just not waiting. Now, there's a term. I'm not trying to teach you how to do asynchronous programming in this class, but there's a term called, you mark the method as async, and then, you mark the class as async, and then you mark the method with a wait. If I was writing this, I would probably, instead of calling it a wait, I would probably call it don't wait, because that's really what it means. What that means is fire this guy off, but just don't wait. Go on, do something else, okay? You don't have to stand there and wait for the toast. Okay. So, do all tasks absolutely, positively have to be notified when they're done? Or is some of them just fire and forget kind of tasks? So, in toast, yeah, I really need to wait for it to go ding so I can take the toast out. But there's other tasks where you just set them up and let them go. And when they finish, that's fine. You don't really care when they finish as long as they get finished sooner or later, right? You don't need a notification that comes back. So, one more time, does it make each individual piece of the breakfast run faster? In other words, does it make the toast run faster? Does it make the scrambled eggs run faster? No! All we're doing is just not waiting. So each individual task does not run faster. Toaster doesn't toast faster. Okay? Good. So, you might ask, well, what problem are we trying to solve? That would be, by the way, that would be a really good test question. What problem are we trying to solve? Well, the problem to solve is, while I'm waiting for the toast, I can't do anything. All right, so let me give you an example. I'm going to fire up another example. I'm going to do file, close on that guy, file, open, and let's go, and let's get this async demo guy. Okay, so here's just an asynchronous demo, and all I'm going to do is take a number, and I'm going to add them together. That's it. Now, I've deliberately thrown a pretty decent weight in here when you start this guy, because otherwise it would run too fast, okay? So when I add my two numbers together, if I go to the add thing, I sleep for 5 seconds. I mean, I have to do, right, so I'm faking it, right? Okay, so I want to run this application. I want you to notice what happens while I'm waiting, all right? So here we go. I fire up my application. And so you know how you can pick this guy up and move him around a little bit, right? Okay, here we go. I'm going to say add. And then I'm going to grab the title bar and start. What's going on? How come I can't move the... Oh. Because I was waiting for that thing to go. My user application was completely locked. I could not move this guy around. I couldn't go do anything else because I was standing there watching the toast. And because I was watching the toast, I could not respond to the mouse moving around. I'm going to do it one more time. Here we go. I'm hitting this, and I grab this. I go, hey, what's going on? How come I can't move it? And then wait 5 seconds, and then it does move. Okay? So, why? What's the use case for doing asynchronous programming? It's to make my user interface not look like it's stuck. Have you ever seen an application where it comes up and says, across the top here, where it says like asynchronous? You ever seen in parentheses not responding? You ever seen one of those? Yeah, I have. Okay, here's another example. There's a website out there called the world's largest website. And let's say you just wanted to count the number of items in there. Okay? So here we go. First of all, let me do an asynchronous count of math. By the way, this is going to take the same amount of time. Okay? We're not talking about going faster. You know, adding these two numbers together, it takes the exact same amount of time, except that I can still go do something else. So I'm not waiting on the toast anymore. Likewise here, if I do an asynchronous version of this, I can move this guy around and ta-da, he spit out the numbers. Okay, so one more time. Why are we doing this? What is the asynchronous thing designed to solve? That's a very simple kind of question. Describe the problem that asynchronous programming was designed to solve? And the answer is, I don't have to wait for the toast, but it makes my user interface not lock up. Okay? That kind of makes sense? Good. Okay. So, there's another one called background worker. Now, this one, as I mentioned before, asynchronous programming does not fire up new tasks. It does not use multiprocessing at all. All I did was just not stick around and wait for the guy to finish. Okay? Okay. So I got one more. By the way, I am going to give you the source code to all this. Whoa, that's not what I wanted. To all this stuff if you wanted to kind of poke around it. Oh, I want open project. And this one's called the background worker. Okay. So background worker does indeed fire up a new thread. Okay. So unlike asynchronous, here I really want to do something different. Now let me give you an example of how to do that. Okay. Let's go back. Let's say that you write an application that downloads a file. I could do this asynchronous, right? Where while I'm downloading, that you could go off and do something else, right? The user interface is not really stuck. But to tell you the truth, when you're downloading a file, maybe you want to like close that window off and go do something completely different and still have it run download. Okay, that's slightly different. That's more than just having the user interface stuck. I want to like close that window or minimize it and then go off and do a completely different task. Okay, that takes different tasks. So background worker was designed specifically for handling those kinds of things. So what this guy does, let me just show you the design here. Okay, so I'm starting up a thread, and then it's just going to march through it. This thing's called a progress bar. Okay, and so the progress bar is just going to go, ka-toink, 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 just move along, showing me that things are actually happening. Okay, so this guy is going to start up a new thread, not like the example before. All right, so here we go. I'm going to do this guy. I'm going to start up the thread, and bam, I get an error message that says cross-threaded operation is not valid. The control, that's the progress bar, access from a thread other than the thread it was created on. Ooh. Okay, we're coming up on the 15-minute mark.